Today we're going to be talking about how to solve triangles that aren't right triangles. Remember the other day we did we used SOHCAHTOA and other rules that worked for right triangles. But what we're doing today is we're going to talk about methods that work for any triangle. So we're going to talk about what is called the law of sines. And the law of sines works if you have two angles and a non-included side, two angles and the included side. Remember, the included side or an included angle means that the side or angle is in between what we're talking about. So like ASA means I have two angles, but then the side between the two. And this will make more sense once we see the law of sines and draw the pictures. And sometimes SSA, so two sides and the non-included angle. And what the law of sines is, it's a ratio that says that the side divided by the sine of that opposite angle is equal to the side length of another side over the sine of the opposite angle. So remember when we label angles and sides, big A and little a are across from each other. They don't touch. Big A is angle A. Little a is side A. Big C is angle C. And then there's side C that's across from it. So law of sines will say that the length of A, this side length divided by the sine of this angle is equal to side B divided by the sine of angle B, and that's equal to side C divided by the sine of angle C. And we can use all three fractions at once, or we can just pick two of them. When I do these problems, I like to draw a picture and make loops, and that makes it a lot easier. So example 1a, let's draw a triangle ABC. A, B, C. And angle A is 28 degrees. Side A is 8. Angle B is 102 degrees. We can figure out what angle C is because 180 minus 102 minus 28, that's going to give us what angle C is. And that looks like it's going to be 50 degrees. 50 degrees. We don't know what side C is, and we don't know what side B is. So we'll have to figure those out. And we're going to use the law of sines for this. And we already know one side and one angle. So that's all we need. So we have 8 divided by the sine of 28 degrees. That's equal to, well, let's figure out B first. We don't know what B is, but we know angle B is 102 degrees. Let's see, we're trying to figure out those, but we know that. So then we can cross multiply. 8 times the sine of 102 degrees equals B times the sine of 28 degrees. Now I'm not going to type in the left side on the calculator. I'm going to divide both sides by sine of 28 degrees first. The reason I'm doing this is so that we get the most accurate answer, so we're not rounding early. These cancel over here, and then pay attention carefully to how I type this into the calculator. First, I'm going to make sure I'm in degree mode because my angles are in degrees. So 8 times the sine of 102, close the parentheses, divided by sine of 28 degrees. And that gives me 16.668, so that's going to be 16.69. And that is the side length of B. Now we're going to do the same thing for C. These two are going to go together. I'm still going to use my pink one here. So 8 over the sine of 28 degrees equals C over the sine of 50 degrees. And again, we'll cross multiply. And when we cross multiply, it's going to be 8 times the sine of 50 degrees equals C times the sine of 28 degrees. And then we'll divide both sides by the sine of 28 degrees. So then I'll type this into my calculator. Now, one of the nice things about our calculator here is I can just go up, highlight this, and hit enter. Because notice the only thing that's different than what we typed in before is that instead of 102, it's 50. And we get 13.05. So now we've solved this triangle. We know what all the sides are and what all the angles are, and we're done. So this law of sines is, it's not complicated to do. It's just making sure you set it up correctly and type things into the calculator the way that we have to. All right, for this pair problem, I'm going to draw the picture and then label it, and then have you guys try the rest. So angle A is 51 degrees. Now we're just drawing a picture to organize our information. Well, angle C is going to be 180 minus 44 minus 51. So in the calculator, when I type that in, I get 85 degrees. So this is 85 degrees. Okay, so now you can loop things that go together, like these will go together, these will go together, and these will go together. All right, so you're going to be using 11 over the sine of 85 because that's the only pair of side and angle that you know both of. So go ahead, pause the video, try this out, just like what we did over here. And then when you're done, unpause the video to check your answers. All right, so you can check your answers with mine and you can see the work. One of the ways I like to double check if I've done this correctly, or at least if my answers make sense, is that the longest side needs to be across from the biggest angle. So you see my biggest side is 11, and that's across from the 85 degree angle, which is the biggest angle. Then my smallest side is side B, which is 7.67, and that's across from the smallest angle, 44 degrees. That just makes me feel that I've done this correctly. It's not a for sure way to do that, but I know that if it wasn't the case, if I got B equals 12, I know that something's wrong. Or if B equaled 9.6, that wouldn't be the smallest side because A is 8.58. So I would be clued in that something is wrong. So law of sines is not too difficult. It looks more confusing than it is. Just make sure you set up the problem correctly and do your cross multiplication. And now on the next page, we're going to talk about using the sine function to calculate area. Now, these three formulas are all to calculate area, and again, it's dependent on what you're given. Notice that we have one of the formulas, side B times C multiplied by the sine of angle A. So if you know two sides and the angle that's in between them, that's what you would use. I have sides AC times the sine of angle B. Again, we're not using side B at all, but we're using the sine of it, the angle measure. And then the last one here, AB times sine of C. So basically what that looks like in the picture is that if I know these two sides and this angle, I can calculate the area. Or if I know these two sides and this angle, I can calculate the area. And then finally, these two sides and this angle, I can calculate the area. So if I know the angle that touches the two sides that I know, that's what I would use to calculate the area. So let's look down here, and we do have that situation. We know angle C right here, and we know the two sides that touch angle C or that form angle C. So this would be like your side A and your side B. So the area formula is 1/2, in this case is going to be A times B times the sine of angle C. So we're just going to put that in the calculator. Okay, and because we're multiplying, it doesn't matter what order we do it in. And I should be consistent and do 1.4 times 2.3 times the sine of 78.1. And then let's throw that in the calculator. Now you could divide by 2 at the very end. I'm going to do 1/2 times 1.4 times 2.3 times the sine of 78.1. And that gives me 1.575 or 1.58. So my area, 1.58 square miles. So again, it's just like with the law of sines where you just plug it into the formula and making sure you typed it incorrectly to get the correct answer. Example number 3, we don't have a picture, so we're going to have to draw one. So I'm just going to draw A, B, C. So the tricky thing about this problem will be labeling things. So it says you lay off lengths of 15 feet and 11 feet for two sides. So we can just label 11 and 15. And then a 62-degree angle in between those. Okay, so that means this angle is 62. So now we can use that formula, because this is side B, this is side A, and I have angle C. Now, no matter how I would have drawn this, I still could have used this formula because the angle that is formed by my two sides is the one that I know. So area equals 1/2 times 15 times 11 times the sine of 62 degrees. And we just throw that junk into the calculator. Actually, it's probably be easier for me to just redo it all. So 1/2 and 15, 11, times the sine of 62, and I get 72.84 square feet. So this day requires, the sameness requires thinking and being able to plug stuff into our formulas. So if you can do that, then you're going to find this lesson particularly easy. So thanks for watching the video. Make sure to like it and subscribe.